Today, I'll investigate 3 different brands of RGB LED smart bulbs with the goal of finding a way to completely control these bulbs locally without a cloud app, the internet, or even Home Assistant. I'll explore different communication protocols, the onboarding processes, and while I'll cover a bit of the Home Assistant integration, my goal is to find a bulb that can be directly controlled locally without the use of any third-party apps, hubs, or platforms. Hi, and welcome to Res and Chem Tech. Now, there are quite a few videos and channels out there that focus on RGB LED light bulbs. But as a general rule, they tend to do things like look at the quality of the bulb itself, things like how many lumens or the brightness produced, the color rendering index, maybe some of the features available with the app. This is not one of those videos. Instead, I need to locate an RGB LED light bulb that can be controlled completely locally. And by locally, I mean without a manufacturer's app, without any internet access, and without any other third-party platforms, even something like Home Assistant or MQTT. I need this for part of a larger project I've alluded to in a couple of my other component videos, but I don't know if such a light bulb even exists. That's what I'm going to try to find out today. For my particular project, I have the following needs for a smart light bulb. First, I need an RGB bulb with dedicated tunable or adjustable white LEDs. So what does this RGBWW really mean? Well, the RGB obviously means that each pixel has a dedicated red, green, and blue LED. But the W means that the pixel also contains one or more dedicated true white LEDs. If only a single white LED is present, as is in this example, it has a fixed temperature or color of white light expressed in Kelvin. The lower the Kelvin number, the warmer the light. Just for reference, a normal incandescent light bulb is generally around 3000 Kelvin. While the white light produced by just combining the RGB LEDs to try to produce white is up somewhere around 7,000 to 8,000 Kelvin. So when using an LED bulb or strip with dedicated white, you need to verify the actual number and types of white LEDs used, as these 4-color LED bulbs or strips can be labeled in multiple ways. Now the first way here is probably the most accurate because it indicates a red, a green, blue, and a single white. But you'll also sometimes see these labeled as RGBWW or RGBCW, where the WW indicates a warm white LED and a CW indicates a cool white LED. But in neither case can you actually change the temperature of the white light unless you try mixing in some of the RGB LEDs to try to produce a particular temperature, but that usually fails to produce a nice quality white light. However, you can also get bulbs and strips with 2 dedicated white LEDs, one of which is a warm white and the other which is a neutral or a cold white. Now unfortunately, these are also often labeled RGBWW, but in this case it means there are red, green, blue, and 2 white LEDs in each pixel. The 2 white LEDs allow the white color temperature to be adjusted by mixing the warm and cool white LEDs. For my project, I want an adjustable white, so I'll need to check the product specs carefully to see if it lists an adjustable white or 2 dedicated white channels. But that's not my only requirement. I want to be able to onboard the bulb to my local network without needing to install a dedicated manufacturer's app or creating yet another cloud account. I want to control the bulb settings such as state, color, and brightness without any external internet access. Now, local Home Assistant MQTT integration would be a bonus, but for my project, I need to be able to directly control the light via a local API or other method that doesn't require any third-party systems like Home Assistant or an MQTT broker. And finally, I'd like to be able to accomplish this without disassembling the bulb to get to the GPIO pins to flash custom firmware or even replacing the controller chip inside. For my initial testing, I selected 3 different types of RGBWW bulbs from 3 different manufacturers. Now again, there are literally hundreds of different options out there, but I tried to pick 3 that represent the more common types available today. Now, none of the manufacturers have provided me any of these products, nor am I being paid anything for using these particular items. I purchased everything you will see myself. Also remember, I'm not looking to compare the quality or the brightness of light produced, but we'll be focusing on the onboarding and control options for each. I'll explore the onboarding options, whether the bulb natively integrates into Home Assistant or what it might take to get it to work with Home Assistant, but more importantly, if there's an API I can use for my project to control the bulb directly. I'll also check out the published specs for each. Let's start with a bulb by a company you've probably heard of if you've done much of anything with LED lighting, and that's Govee. Now, I want to provide complete transparency here. This is actually the first Govee product that I've purchased. Not that I personally have anything against Govee. From other videos I've seen, they make quality products. But as you know, if you watch my channel much, I like to create DIY versions of commercial products. So I've already created my own versions of the Govee Lyra floor lamps and the Govee LED curtain. But I don't want to create my own DIY version of a light bulb, so I opted to give the Govee bulb a shot. Now I'll provide links to everything I show down in the video description, but if you look at the particular product description from the Amazon listing, we can see that this is a 1000 lumen or 75 watt equivalent LED bulb. It also has dedicated tunable white LEDs adjustable from 2700 to 6500 Kelvin. This listing also indicates that this is a Wi-Fi bulb. But of course, as I've shown in other videos, you can't always trust the specs listed on Amazon. But in this case, the actual specs listed on the box match what it says on Amazon. There is one additional spec there that you likely wouldn't care about if you're just putting this bulb in a lamp or fixture, but that's the current draw. That's an important spec when designing your own DIY projects as I am, so it's nice to know the current draw without needing to actually measure it. Of course, the first step with most Wi-Fi based smart devices is that I need to get it onto my own local Wi-Fi. Now, looking at the Govee instruction manual, the first step, naturally, is to download and install their app and create a cloud account. That's an immediate showstopper for my project. But notice that it's using Bluetooth to make the initial connection for onboarding. That means the bulb has both Bluetooth and Wi-Fi available. So might there be a way to use the Bluetooth to onboard this without using the app? Let's find out. I've not actually powered this bulb on before right now for the first time, but let's go ahead and turn this on and see what it does. Whoa, that is extremely bright. It's definitely going to be a bright enough bulb for my needs, but obviously it's not flashing or using any kind of certain color to indicate that it's ready to be onboarded. But according to the manual, it's going to use Bluetooth, so let's bring up my phone and see if we can find a new Bluetooth device. Now I'll use my phone and I'll actually scan to see if it sees any new Bluetooth devices. This will take just a second or two, but I would expect to see something along the lines of Govee or bulb or something show up down here if it finds something. And as I see right now, it does not look like anything new has been discovered. So why it may be broadcasting Bluetooth, I'm not able to pick it up directly with my phone, which means I'm probably going to need to use the app. So this first Govee bulb is pretty much already a dead option for my needs. But let's go ahead and onboard it with the Govee app and see if there might be local control options that can be enabled once it's actually on my Wi-Fi. So an interesting little tidbit. I decided if I was going to install the Govee app, I actually was going to do it on an old phone that I had laying around instead of my primary phone. When I brought this phone up and actually turned on the Bluetooth and scanned, it actually did find the bulb. Why I wasn't finding it with my other phone, I have no idea. They're both Samsungs. One's an S10, one's an S24. But let me go ahead and see if I can connect to this. Okay, right now it says an app is needed to use the device, but I'm going to go ahead and let this pair anyway, just to see what happens. Now it does have a question mark here, and exactly that's what's happening here. The Bluetooth device requires an app to connect. So even though I was able to see the Bluetooth device on this particular phone, I still can't pair with it and do anything. It's not on Wi-Fi, so I don't have an IP address to go to. It does look like I'm stuck with installing the Govee Home app. Okay, as I mentioned, I am actually using an old phone here. It no longer has cellular service, but it does still have Wi-Fi, so it should just work fine. I've gone ahead and downloaded and installed the Govee Home app, but I've not launched it yet. So let's go ahead and launch this and see what we get into. And we're going to get a screen of a whole bunch of different features, things that it can do. And of course, there's an agreement policy, so we've got to accept that. Okay, now I've not created any kind of account or logged in yet, but we're going to go ahead and see if it can find the device. And let's see, we are looking at bulbs, so we will find the bulbs down here somewhere. There we go. Okay, I happen to know, again, looking at the box, this is, okay, I finally found the model number. It's an H6006, so we're going to select that. Okay, now here it is. I have to create a Govee account. So as much as I hate to do that, I'm going to go ahead and use a junk email address, create a password, just so I can get it in here and log in. Okay, I created my account, went through all the verification steps, had to enable some additional permissions on my phone for location and a whole bunch of other stuff, but it did finally find the device on here. So I'm going to go ahead and add that. And now it's making a connection and it's showing Bluetooth there. So we're just going to call this Govee test bulb and say done. Okay, now it's looking for the Wi-Fi settings, and now it wants the Wi-Fi password. Okay, so now I've entered in my Wi-Fi password. We'll go ahead and click done, see if it connects to my Wi-Fi. Okay, and now we are connected. We'll take a look and get the IP address in here just a second, but let's see exactly what all we can do with this now that we're here. First thing I want to do is let's turn down that brightness. Okay, so we have that working where we can control the brightness. I'm assuming we can easily switch colors now. We can. So all that's working, but again, it's working through the Govee cloud using this app and an online cloud account, which simply won't work for the project I'm planning. So one of the first things I tried was I was able to get the MAC address of the bulb, find the IP address that was assigned by my router, and then I tried to go to that IP address hoping maybe there was some sort of web interface that I could access directly, and that might give me some options for controlling it. But as you can see here, there obviously isn't any kind of local web server, so I'm not able to access the bulb directly via Wi-Fi. And out of curiosity, I also checked Home Assistant to see if anything had been automatically discovered there, and nothing new is showing up under Home Assistant either. Now, I know it's certainly possible to integrate Govee bulbs like this. I believe there are some HACS components and things available or other workarounds that you can do, but for my particular project where I need to control the bulb directly without using Home Assistant, it's pretty much a non-starter. There's only one remaining possible option. Looking just a bit more into the Home Assistant integration, I did find this Govee local integration that says it uses a local API control, so that's promising, but it says you have to enable local control on your Govee device and refer to the instructions available here. So really what this means is once I use the Govee app and onboard it, if supported, I would be able to enable local LAN control, and I believe it uses MQTT, but then I would actually be able to control this bulb locally, which is promising. But unfortunately, in my case, the particular model of bulb I bought does not offer that local control. So if I bought a different Govee bulb, I might have an option, but the way it stands right now, this Govee bulb isn't going to work for my needs, so I'm going to go ahead and set it aside and move on to the next. Next up is this RGBWW bulb by ThirdReality. As you can plainly see from the Amazon listing, this is a Zigbee bulb. That means the control will be local by nature, as long as you have a Zigbee coordinator. In my case, I do already have a Zigbee network up and running, so I suspect this particular bulb will be very easy to add in Home Assistant. Looking at the specs on the box and in the included small instruction guide, this bulb is only 800 lumens, so it won't be quite as bright at maximum as the Govee bulb, but it does have the same color temperature range. And again, as you can see here, it is using Zigbee instead of Wi-Fi for the communication protocol. Now, I've not powered on this bulb before, but according to the instructions, when the bulb first powers on, it should flash warm white, cool white, red, green, and blue before turning solid warm white again. At that point, it means it's ready to be onboarded, and I'll have 3 minutes to adopt it via the Zigbee integration in Home Assistant. If successful, the bulb will flash, then turn warm white, and at that point, we should be able to see and control it in Home Assistant. Let's give it a try. Okay, there we go. I see it flashing. Okay, it's flashed all its color, and at this point, it should be ready to go. So we'll jump over here to Home Assistant. We will go into our integrations. We will go into our Zigbee, and we will say Add Device, and we will wait for a second and see if Home Assistant is able to find it. And there it goes. The light actually flashed. It is configuring that bulb, and right there, the bulb is already ready to use. I'm not going to assign an area for it, but let's just go ahead and go back. And if we go back again to our Zigbee devices, we should now find, there it is, the ThirdReality bulb, and we see we have all these controls available. Okay, so I've displayed the bulb again so we can see it and take a look at some of these controls in Home Assistant. This obviously is my main power switch, so that works just without any problem. If I click into the bulb here, see we've got a number of different settings. This is the brightness. I'm going to turn this down a little bit, so hopefully it doesn't quite overwhelm the camera too much. So we do have brightness control, that's fine. This is our color control, so we can try blue, and we can try red, we can try green. All those are working just fine. Now let's take a look at the temperature setting. I'm initially going to bring this up here and set this somewhere around 3000, which is about the color of an incandescent bulb. And looking at it, I can say, yeah, it's pretty close to incandescent. we can go all the way to the warmest setting, which is kind of a yellow or orangish, and you probably can't see this on the camera as well, all the way to the warmest setting, which is more of a bluish white. So everything there is working. It's working locally. It was very easy to onboard the Home Assistant. I didn't have to download any apps or create any cloud accounts. So it seems like the perfect bulb. But it still may not be right for my particular project. For my planned project, I'll have not one, not two, but counting the light bulb, a total of 3 different controllers. Now these controllers all need to communicate with each other. As a Home Assistant user, I could easily use that as the center hub to allow the devices to talk to each other. But while I want Home Assistant integration to be an option, I don't want it to be required so that folks that aren't Home Assistant users can still duplicate the project. That means that all 3 controllers need to be able to communicate with each other directly. Zigbee is certainly an option for this, but it would require use of a special ESP32 controller that supports Zigbee, such as the ESP32C6, and unless extra processing was used to make one of the ESP32 controllers a Zigbee coordinator, the end user would still need an established Zigbee network. So the goal is that the project will only require Wi-Fi for full functionality. Things like Home Assistant and MQTT would be optional for integration, but not required for the project's full functionality. So Zigbee is still a possibility, but not the ideal solution in my case. However, there is still one light bulb to investigate. The last bulb I'm going to investigate shows the most promise. This is the Kauf RGBWW Wi-Fi bulb. In fact, I want to show a couple things from the product description in more detail. This bulb comes with ESPHome pre-installed. And while ESPHome has tight integration with Home Assistant, it also has an HTTP API that allows control without Home Assistant. But what's more, the controller is actually an ESP8266, so I can even flash different firmware like Tasmota if desired, which also has an API for local control without a hub or central controller like Home Assistant. And before you ask, no, you can't directly flash WLED onto the bulb, but it can be controlled by WLED or XLights via DDP or Distributed Display Protocol. In fact, the entire bulb is open source. Within the GitHub repo, you can find ESPHome YAML configuration files, pre-compiled binaries for Tasmota, and a whole lot of other information. In fact, the Kauf Common repository for all Kauf products even provides the ESPHome HTTP API commands, which is perfect for my needs. There is also a ton of troubleshooting information. I think this is the bulb I've been looking for. Let's take a look at the other specs for the bulb. As I've already covered, it has a programmable ESP8266 chip, has ESPHome pre-installed, but can be flashed with Tasmota or other compatible firmware. In fact, the included instruction manual not only provides details on installing Tasmota, it provides the GPIO pinouts for the 5 different LEDs. And yes, it does have the desired 5 LEDs, including a warm white and cool white, and the same temperature range as the other 2 bulbs. But there is one thing to be aware of about this particular bulb when compared to the other 2. The Kauf bulb is significantly bigger than the other 2. While all 3 use an E26 base, which is a standard for normal light sockets in the US, the other 2 bulbs are A16 in size, while the Kauf bulb is an A21. This means it might not fit in some standard light fixtures, but you can get Kauf bulbs in other sizes like A15. For me, the larger size is fine, so let's fire it up and see how it onboards. If you've ever onboarded an ESP-based device before, then this process will be very familiar. When the bulb first powers on, it will attempt to connect to Wi-Fi. If it can't connect, it will begin broadcasting a Wi-Fi hotspot, in this case named Kauf bulb, followed by the last 6 characters of the MAC address. Using a phone, tablet, or a laptop, you can connect to this hotspot and will display a portal where you can enter your Wi-Fi credentials. Now, according to the instructions, the bulb will power on by default, but won't use any sort of indication saying the bulb is ready for onboarding like the ThirdReality bulb did. Let's go ahead and power this on. After a moment or two, the hotspot should begin broadcasting, so let's pull up my phone and look for that hotspot. There you can see the Kauf bulb hotspot being broadcast. So I need to connect to this, but unfortunately when I actually connect to this, it's going to take my phone off the Wi-Fi and I can no longer show my phone screen live, so I will use captured screenshots for the rest of the process. After I joined the hotspot, I opened up a browser and went to 192.168.4.1, and yes, that is listed in the instructions. It shows all the various SSIDs found, so you can select the desired SSID or simply type it into the box, then supply your password. However, before I save this, note that if you scroll to the bottom of this page, you can also flash alternate firmware like Tasmota right here from the onboarding page. The instructions in the Kauf website have full details on how to do this, but for now I'm just going to stick with the default ESPHome. So once you have your SSID and password entered, just hit save. The board will reboot and attempt to connect to your Wi-Fi. Now, the bulb actually flashed when this happened, but I didn't catch it on camera. However, the hotspot quit broadcasting. I was able to find the device via my router, so it is now successfully on my Wi-Fi network. Let's take a quick peek at Home Assistant. Going over to the integrations page in Home Assistant, notice right up here at the top that the Kauf bulb was automatically discovered. I didn't have to do a thing, it just showed up in Home Assistant. Now I can simply add this, but before I do that, let's go over and take a quick peek at ESPHome. In the ESPHome dashboard, note the message at the top that indicates a new device has been discovered. If I click Show, and there's my Kauf bulb ESPHome node. Again, this is with no interaction on my part. But before I actually take control of this node and add it to Home Assistant, I wanted to show that the Kauf bulb actually has its own local web server. And we can reach that by the IP address if we know it, or we can open up a browser and just add local to the current device name. The local web server shows a lot of useful information, including the assigned IP address if I hadn't got that from the router. It also shows the live ESPHome log. Now note that I'm receiving a lot of API errors right now because I haven't yet adopted it into Home Assistant. But more importantly, I even have full control of the device right here from the website. So I can do things like turn it off and on, I can adjust the brightness, the color, everything else right here from the website. And this is not using Home Assistant or ESPHome at all because I haven't yet adopted those. In fact, I ought to be able to open up a browser and actually use an HTTP command to send directly to the bulb. Here I've opened up a new browser tab. I'm using the assigned IP address of the bulb followed by a special URL or HTTP API command. Now these are listed in the Kauf HA GitHub repo, but for example, by changing this last part of this from turn on to turn off, you can see I'm actually able to control the bulb directly from a web browser without using ESPHome or Home Assistant, as it hasn't been adopted into either one of those yet. Note that I can also do things like turn the bulb on and actually set the color, all from an HTTP post message without any other systems. Now this is exactly what I need for my project, but let's go ahead and take control of the ESPHome node and add it to Home Assistant. Note that I could theoretically add the bulb to Home Assistant without taking control of the ESPHome node. All the ESPHome functionality is already installed. But if you notice from the web page info, this is running an older version of ESPHome. If I want to update it to the latest version and receive future update notices, I need to add the node to ESPHome. In my case, I may also want to add additional functionality down the road, which will require modifying and flashing an updated ESPHome configuration. But you probably also want to consider renaming the device, which will also impact the name of all the created Home Assistant entities. If I do that here in ESPHome before I adopt the integration in Home Assistant, I won't have to manually rename all those created entities on the Home Assistant side. Now, the Kauf website includes instructions along with a nice step-by-step video of the process of renaming the device in ESPHome. So I'm not going to cover that here, but I'll adopt it, make the name changes to my node, and then come right back. Okay, you can see here that I've renamed the node, and while I said I wasn't going to go into details, I do want to show you just how simple the base configuration really is. So we'll edit this. Let me make that a little bit bigger so you can see it. And all I really did here was come in and change the name. Now, I did go ahead and add a friendly name, which is recommended. Now, one thing I'm not overly thrilled about here is that it pulls all the necessary YAML for the bulb in from the Kauf HA GitHub repo. This means that future updates, compiles, and uploads depend upon this repo being available and reachable. The advantage of this method is that if a future ESPHome update has a breaking change that impacts the bulb and Kauf HA updates the YAML to address this change, you don't need to do anything on your end. The latest and greatest YAML will always be imported. However, this does add an external dependency I really don't care for. Now, luckily, the full YAML configuration file is also available in the GitHub repo, so I could replace my current code with the full YAML and remove any external dependencies. Of course, then I'm responsible for any future updates and fixes. For now, I'll leave it as is, and as an extra precaution, I'll make a local copy of the full YAML version, and I'll also fork or clone the repository. That way, in some unlikely event the project is abandoned by the original developer or the Kauf GitHub repo becomes unavailable, I'll still have my own copy of both the repository and the full YAML version. I've gone ahead and completed those steps, including flashing the updated YAML to the bulb. But for now, with the device renamed, we're ready to actually integrate it into Home Assistant. Back over on the Home Assistant integrations page, you see that I still have a discovered device, but now it has the new name and friendly name that I assigned. All I have to do is click Add, confirm that, and that's it. I can optionally assign an area here. I'm going to go ahead and put this in bedroom 2 because that's going to be the additional spot. And there is my full entity in ESPHome and Home Assistant. And as would be expected, I now have full control over the device, including things like power, things like color, brightness level, and even the white temperature setting. So I'm now able to completely control the bulb via Home Assistant. Yet, even though I do have the ability to control everything through Home Assistant, I don't have to use Home Assistant. I still have the ability to use the HTTP API to control the bulb. This is the best of both worlds and exactly what I need for my project. So, by utilizing the Kauf bulb with ESPHome pre-installed, I now have a multitude of control options. Of course, I can use Home Assistant if I have it, or I could add MQTT to the ESPHome configuration if I have an MQTT broker, or I could even use the local web server that's pre-installed. But more important for my project, I now have multiple ways to communicate directly with the bulb. I still have the HTTP API I showed before, but I can also use something like ESPNow, which allows ESP boards to exchange small amounts of data directly, or I could even use the ESPHome API, even if I don't have ESPHome installed. I do note that you can install and use a local version of ESPHome without Home Assistant should you need to modify the default YAML, as I demonstrated earlier, and I'll provide a link for more information on that topic if interested. But as a Home Assistant user who also wants to build a multi-controller project that doesn't require Home Assistant, this Kauf bulb provides me everything I need. So while I may have found the perfect bulb for my project, your needs are likely to be different. And while things like the lumens or brightness and the color rendering index and other features are important, just know that there are a multitude of different RGB LED bulbs out there, and you can probably find one that's perfect for your needs as well. Now, I know I've alluded to this secret bigger project that I've been working on in quite a few videos now, and I am still working on it. But until I have more to share on that, I do plan on continuing to release more videos on DIY electronics, LEDs, and Home Assistant. But until that time, I'd like to say thank you for watching, and I hope to see you again soon.